The world's oceans are facing unprecedented challenges. They are vast, beautiful, and critically important. Yet human activities are pushing them to their limits. Climate change warms the waters and makes them more acidic. Overfishing depletes fish stocks at an alarming rate, disrupting delicate food webs. Pollution, from plastics to chemicals, chokes marine life and habitats. Coral reefs are bleaching. Fish populations are dwindling. The cry for help from our oceans is growing louder each day. We must act decisively and swiftly. The sheer scale of the ocean makes conservation a monumental task. Traditional methods of study, while valuable, often fall short. We cannot effectively protect what we do not fully understand. Imagine trying to manage a vast, unseen kingdom with only fleeting glimpses. This has been our reality for too long. The challenges are immense, but so too is the potential for innovation. We need new tools, new approaches. Fortunately, technology offers a powerful lifeline. It provides us with new eyes and ears to explore the ocean's depths. Innovations are emerging at a remarkable pace. These tools allow us to monitor marine environments more comprehensively than ever before. They offer a beacon of hope, illuminating a path towards a healthier, more resilient marine world. Autonomous underwater vehicles, or AUVs, are remarkable machines. They are like robotic submarines, untethered and free-roaming. Scientists program them with a mission. Then, these AUVs glide silently through the water for hours or even days. They collect a vast array of data. They can map the seabed in incredible detail using sonar. They can measure water temperature, salinity, and oxygen levels. They can carry cameras to capture images of deep-sea life. These vehicles venture where humans cannot easily go, unlocking secrets of the abyss. Remotely operated vehicles, or ROVs, are another vital tool. Unlike AUVs, ROVs are usually connected to a ship by a tether. This cable provides power and allows for real-time communication. Pilots on the surface control the ROV's movements and its instruments. ROVs often have manipulator arms. These arms can collect samples of rocks, sediment, or even delicate marine organisms. They can also be used to deploy or recover equipment on the seabed. These underwater robots have revolutionized deep-sea exploration. They help us discover new species, from bizarre fish to unique corals. Sound travels exceptionally well underwater, much better than light. This makes acoustics a powerful tool for studying the marine environment. Hydrophones are essentially underwater microphones. Scientists deploy them in various ways. They can be moored to the seabed, dangled from buoys, or towed behind ships. Some are even attached to marine animals. These sensitive instruments listen to the symphony of sounds the ocean produces. They pick up everything from the clicks of dolphins to the songs of whales and the grunts of fish. This acoustic monitoring provides invaluable insights into marine life. Many marine animals rely heavily on sound for communication, navigation, and finding food. By listening to their calls, scientists can track their movements and estimate population sizes. For example, hydrophone arrays can monitor whale migrations across vast ocean basins. They can help identify important breeding grounds or feeding areas. In the coastal waters of Kerala, acoustic studies can reveal the behavior of local dolphin populations or the timing of fish spawning. To understand a patient, a doctor takes their pulse and temperature. Similarly, to understand the ocean, we need to measure its vital signs. Advanced ocean sensors are our tools for this critical task. These sophisticated instruments can measure a wide range of parameters. They track water temperature, salinity, and pH levels. They monitor dissolved oxygen, which is essential for marine life. They can also detect chlorophyll, an indicator of phytoplankton, the base of the marine food web. These sensors are becoming smaller, more accurate, and more affordable. They are placed on fixed moorings and buoys that float on the surface. They are carried by autonomous gliders that patrol the ocean for months. Some are even attached to marine animals like seals or turtles, turning them into oceanographers. Many of these sensors transmit their data in real time via satellite. This gives scientists an up-to-the-minute picture of ocean conditions. This constant stream of information is vital for tracking changes and understanding long-term trends in our marine ecosystems. The data from these sensors is particularly crucial for monitoring the impacts of climate change. Rising global temperatures are causing ocean warming. Section 5. Eyes in the sky, drones guarding our coasts. Drones, or unmanned aerial vehicles, UAVs, have rapidly become indispensable tools for coastal conservation. These relatively small remote-controlled aircraft offer a bird's-eye view of coastal ecosystems. They are far cheaper and more flexible to operate than traditional aircraft or satellites. Equipped with high-resolution cameras and various sensors, drones can capture detailed imagery and data. This allows for frequent and targeted monitoring of dynamic coastal environments. Their versatility makes them suitable for a wide range of conservation tasks. The applications of drones in coastal stewardship are numerous and growing. They are used to map coastal erosion with remarkable accuracy, helping communities plan for sea level rise. They can monitor the health and extent of vital habitats like mangrove forests and seagrass beds. These ecosystems are crucial nurseries for fish and protect coastlines from storms. Drones can also quickly survey large areas to detect illegal fishing activities or pollution incidents, such as oil spills, close to the shore. This rapid assessment capability is vital for effective enforcement and response. Section 6. Turning the tide on pollution, cleaning up and rebuilding marine homes. Plastic pollution is a scourge upon our oceans. Millions of tons of plastic enter the marine environment each year. It entangles wildlife, is ingested by animals mistaking it for food, and breaks down into harmful microplastics. These tiny particles enter the food chain, with unknown consequences for marine ecosystems and human health. The scale of the problem is daunting. It requires innovative solutions to both prevent plastic from entering the ocean and to clean up what is already there. Technology is rising to this challenge. Several promising technological innovations are being developed to tackle plastic pollution. Some companies are designing AI-powered barriers for rivers. These systems can identify and intercept plastic waste before it reaches the sea. Autonomous drones, both aerial and water-based, are being tested to locate and collect floating debris in coastal areas and harbors. Section 7. Decoding the blue AI and the data deluge. The new generation of marine technologies is generating an unprecedented amount of data. AUVs, sensors, drones, and acoustic monitors are constantly collecting information. This creates a data deluge, vast datasets that are too large and complex for traditional analysis methods. This is where big data analytics and artificial intelligence, AI, come into play. These powerful computational tools are essential for transforming raw data into meaningful insights. They help us see patterns and understand processes that would otherwise remain hidden in the noise. Artificial intelligence, particularly machine learning, is revolutionizing how we process marine data. AI algorithms can be trained to automatically identify species from underwater images or videos. This dramatically speeds up biodiversity assessments. AI can detect anomalies in sensor data, flagging potential pollution events or equipment malfunctions. It can analyze vast acoustic datasets to distinguish between different whale calls or identify the sounds of illegal fishing vessels. Section 8. A shared endeavor. Unity for ocean protection. Technology, however advanced, is not a magic solution on its own. Its true power in marine conservation is realized when combined with human collaboration. Protecting our vast and interconnected oceans requires a united front. No single entity, whether a government, research institution, or tech company, can tackle this challenge alone. Partnerships are essential to drive innovation, implement solutions effectively, and ensure long-term success. This collaborative spirit must permeate all levels of conservation efforts. Effective marine conservation technology often arises from close collaboration between different fields of expertise. Marine biologists who understand the ecological challenges must work hand in hand with engineers and technologists who can design and build the tools. Computer scientists are needed to develop the software and AI algorithms to analyze the data. This interdisciplinary approach ensures that the technologies developed are fit for purpose, addressing real-world conservation needs. Such partnerships foster innovation and accelerate the translation of research into practical applications in the field. Section 9. A Sea of Hope, the technological dawn for marine worlds. The journey through the landscape of marine conservation technology reveals a remarkable array of tools. From deep-sea robots to eyes in the sky and the power of artificial intelligence, innovation is transforming our ability to understand and protect the oceans. We can now explore previously inaccessible realms. We can monitor changes in real time. We can even begin to restore what has been lost. This technological prowess offers significant potential to turn the tide against the threats facing our marine ecosystems. It is a new dawn for how we interact with the blue parts of our planet. However, we must also acknowledge the challenges that lie ahead. Many advanced technologies are still expensive, limiting their accessibility, particularly for developing nations. There is a need for more skilled personnel to operate these tools and analyze the complex data they generate. Data sharing can be hampered by logistical or political barriers. Ethical considerations, such as data privacy and the potential impact of autonomous systems, also need careful thought and management. Overcoming these hurdles will require sustained commitment and investment. The key to unlocking the full potential of marine conservation technology lies in continued research and innovation. We must strive to make these tools more affordable, more robust, and easier to use.